Ladies and gentlemen, welcome to today's Geotalk. Thank you for joining us from wherever you are. Today we welcome Professor Moctar Doucouré from the Nelson Mandela University to the Geotalk stage for a rather special talk where we honor the scientific and Earth stewardship legacy of Maarten de Wit and also learn more about Moctar's research with Maarten de Wit. So let's give a brief introduction to Moctar. Moctar has interest in geophysics and remote sensing and is a geophysicist by training. He did his PhD in France at Paris 7 University on marine global geophysics, and thereafter came to South Africa and has published many papers on Southern African geology and geophysics and many interrelated topics. Now, Moctar is currently the Managing Director of the Africa Earth Observatory Network, as well as the Earth Stewardship Science Research Institute, and is also an Associate Professor in the Geology Department at Nelson Mandela University. Moctar has worked in the Bernard Price Institute, at Wits, at UCT, and at De Beers, and in 2011 joined the Nelson Mandela University together with Maarten and has worked with him since then. So Moctar, thank you very much for agreeing to give this Geotalk. We have around 50 people in the audience already, so thank you to everyone who's joined us, and of course thank you to John Hancock's and CCIC Cole for sponsoring these online events. Someone has already asked in the Q&A, and they remain anonymous, where the drinks are. They are virtual, just in case you were wondering. You're no knock on your door with drinks anytime soon. But you can join us after the talk for a virtual networking session on Zoom, and I'll post the details of that in the Q&A at the end of the talk. So Moctar, thank you very much. Over to you. You can unmute yourself and share your screen, and we'll get you set up.
Okay, so I'm about to share my screen. Can you see me?
Just give it a moment. I don't see anything yet.
Okay, can you see my screen?
Not yet.
Not yet. Okay, I did share though. Let me minimize the presentation, go back to the screen. Okay, I'll do it again.
Yep.
It should be shared now.
Yes, now it is coming up.
Okay, great.
Just give it a moment before you begin.
All right.
Yes, so you can now put your presentation into full screen mode. I'm just getting your video up, and you are now live. The audience can see you, and we can see your PowerPoint. So you're set to go, Moctar. Thank you very much. Over to you.
Thank you, Grant. So in this talk, what I really want to do, obviously there is no time to say everything. So what I've decided to do is to give you 3 milestones. And through that, the bit of research work I've done while at AEON, just to illustrate some of the activities that were going on. So those milestones, because this is a story, so and it is told around 3 milestones. So it's when we started as the Center for Interactive Graphical Computing of Earth Systems, and then Earth Systems science become really what AEON as it started was about. And then the last milestone is the Earth Stewardship Science Research Institute. So in this picture here, you have basically a summary, a visual summary of the Center for Interactive Graphical Computing. At the top, you have the free runner of the center. I was mainly dealing with infrastructure, IT, and of course the geophysics side. Christine Thiart in the middle of the picture has been the backbone of the GIS and spatial statistics, mainly for Gondwana. And you can see her to the right bottom of the screen at the station. Here we had really the best machines at the time, and the system was, the platform was micro, the micro, I forgot now, anyway, it has been a while, but it was Intergraph systems. And and it was very different from the Esri software that came much later. And you will see in the next few slides that we had to actually go through that conversion. And Christine has been holding that. And that was through this project of basically creating a Gondwana metal potential GIS. Basically the idea being to merge the Precambrian geology and mineral deposits of Gondwana. The GIS obviously was being developed, and the plan is, and that's the rationale for joining forces with the BRGM at the time, because they had fully fledged ArcView and expert in that at the time. So the full ArcGIS wasn't still around. So, but it was quite a mission to go from the Intergraph database system to converting it to SQL Server environment and then take it into Arc. The idea being to produce a CD-ROM for Gondwana that we call Gondwana Georama, and that will become available to the broader community and industry. So that is really something that was important to AEON at the time. And of course, it was in those years also that the CIGC hosted the technical backup side of the Campbell seismic experiments. You can see here for those, many of you would know, I mean, these data sets have run through at least 2 generations of seismologists and other geoscientists, particularly in the geochemistry side. But, you know, in terms of a seismic, the data was all gathered from the field to our center, and from there, from a sound system, Solaris sound system, taken to backed up and sent to the IRIS system, to the IRIS data center in the US. So that is really one other key project that really kept us busy at the center. Of course, when AEON, properly named as such, started, of course, it was about a new multidisciplinary, inter-institutional and international Earth System Center in Africa. So that is really what makes it different now from the CIGCES. And it has a few pillars, and one was the analytical science and technology, basically the Earth Lab. And then we had the Earth Brain, information digital technology. The third pillar that I'm not showing here because I'm not touching on it, essentially, we don't have time, but that was called I will come to that in the next slide. The R&D was really another strong component. In fact, the rationale for the existence of AEON, dealing with the co-evolution of the African continent surrounding oceans and the biota. Of course, Africa's natural resources and society. So we had in this very good focus, and the Earth Lab finally became a reality, and with analytical equipment. Here you see at the top microprobe system, and at the bottom you have 2 multi-collectors. On the left you have the laser ablation multi-collector, and the RCPMS to the right. So this gives you a context of the kind of capacity AEON developed when it became a reality in those early years. And of course, the foundation and the vision was all encapsulated into this diagram here. And there are 4 tools that are run commons. You have essentially all these, the 2 Earthbrain and Earthlab, and it was Earthwise that I was just trying to remember to mention. Of course, you have a common thread, which is memory, common science, coevolution, and the common product, space, time, data, matrix, and of course, applications related to that. So this just to show you briefly that the kind of product that were being developed, but it was all around the continent of Africa. On the left, you have an emphasis on the kind of time scale that was looked at right from the origin of life to the Anthropocene. So that is an interesting aspect. And of course, many different projects were developed, which I'm not near touching on in this talk. But here you have the building AEON was hosted in at the University of Cape Town at the time. And of course, a major part of our activity and my activity was about fundraising for a new building to enable the vision being implemented fully and bring everything together in one building. So that is what we have been trying to do in this kind of architectural plan that was designed specifically for the purpose of AEON. And of course, it was a major process, and we used to say, of course, all major credit cards are accepted. Of course, it involved lobbying companies, etc. So, but in a nutshell, what this building was expected to do is to host an article facility at the bottom, being basically naturally air conditioned, and the different hubs at the top, the different threads. So, and of course, it was a time when we're pre-Google days, can you believe it? The key engine at the time for surfing was Netscape. And this shows you the first website, and developed with HTML at its raw when it started. But it was around all Earth system science moving to Earth stewardship science. This slide just summarizes what I've said so far. To the bottom left, you see here the time and space scale. It's a bit too small to read. I'm moving on. Now, the real challenge in looking at the Earth systems and moving to Earth stewardship science was in the cost of nature's ecosystem services. And that became really a foundation for everything we were doing, and it drove the Earth stewardship development to the extent that you will see later in this presentation. So it's about nature as a service industry, and that the world, of course, you read some figures here. These were properly researched, not just thrown out. The key workers on this subject are Constanza and collaborators. It's about pressing the planet, but essentially valuing the world's ecosystem services and natural capital. So, and the diagram to the right is too complex. I'll not go into it. We don't have the time, but it shows a materially closed Earth system. And to get out of that, and to also make the base of Africa's natural resources for society in Africa, we needed to look at the genesis and structure of Africa resources. And in that context, we have done work in West Africa, Central Africa, and North Africa. There is no space here to bring those into detail, in any detail, but the ecological economics of Africa resources is central to the Earth Stewardship science. Africa's commons in society, Africa's environmental hazard. Of course, I will not touch on the resource curse that we all know. This just shows the kind of fun we're having at the time, just playing with all different aspects of a continent, viewed from the space, viewed from the interior. You see here on the bottom left something about the geoid, specific mass distribution, supposed to be gravity in that sense. The bimodal surface elevation, I will touch on that briefly later, but also the subsurface and looking at kimberlite, seismic velocity anomalies down to the mantle. So that's basically the perspective. One of the work I've done at the time was looking at the gravity of Gondwana. And it was very tentative at the time. Of course, access to data was the most challenging, but using some models, and we'll show you just now. In fact, it's mentioned there. It's an Ohio State University model, and one could calculate a data model, which you can see on the left compared to the ground data. Is fairly coarse, but it was enough to have spatial resolution of 55 kilometers to look at Gondwana. Here you have Bouguer gravity, major tectonic boundaries, just manipulating the data differently, and major geotectonic clusters of Gondwana, looking at the gradients of the data set. So that's one work that just was finite in a way because of inherent data limitations. And then I also looked at the Africa present day topography. So that was one interesting work, and always in collaboration with Maarten. It was to look at how can we model, can we say something about the topography of Africa? So, and I will not go into details because I'm watching my time here. But what has been outlined is the Anomalisa Topography that is associated with mantle anomalies and volcanics. You can see here the color distinction is evident, but what appears is that the elevated topography is not related to compressional plate margins, which typically is where you see elevated surfaces generally. So, in Africa, this is something that needs to be looked at differently. So we then came up with this inherited old, that is, origin of a present day bimodal topography. So as dating from at least the Upper Paleozoic times, but during which Africa was largely a low-lying continent dominated by its cratons. So that is one takeaway from this exercise on the topography. And then this part of the work we did was exciting because it was looking at elastic behavior of a lithosphere, the competent lithosphere, but also linking it somehow to plate tectonics. This was at the time we've just also finished some seismic work, students were doing some modeling, so it was interesting. I just want to touch a little bit on this because many students have no knowledge today of this topic. So just to mention that it's really looking at, start by looking at the continental effective elastic thickness, and which is defined simply as a yield stress envelope, in terms of thickness, and it's adding you individual layers, and with that expression there, and we are able to then further analyze the type of behavior of the upper mantle, whether you have a crust that is coupled with it, in other words, the lithosphere, or whether the crust is decoupled from the upper mantle. So that is proved to be an interesting exercise at the time, and one can look at this type of cartoon to describe the regime of coupling, and whether the strong upper crust is distinct from the strong upper mantle in terms of phreology. One can then express the elastic thickness as a function of these parameters as shown. And so it's become an interesting way to look at, to say something about the history, the past and the present in terms of the South African lithosphere, where we had the data and completed the exercise. So these are just defining, the different regimes. And the result of that work here is in terms of the map to the right. The different phreology, the different regimes are shown to the left. And that's an interesting spatial distribution within the lithosphere in South Africa. So that's the result. You can see the maxima, the saddle running really almost in the middle of the crater. Next, it is Africa Life Corridors that took also significant effort and time from in terms of AEON's activity, and you have essentially a key underlying driver, and that is to stem the sixth extinction. So you can see, and that's illustrated on the left. You see here all the extinctions in red. The idea is now to be able to cater for the Earth, for our commons in such a way that the sixth extinction is avoided. So of course, Africa Life Corridors has turned out to be more than that, challenging. I will not say more about it because it will take the rest of the time we have. But just to say that an interesting area or corridor where there is a lot of work, the initial work was started, is the corridor that is called the cradle of life to the cradle of humanity. And that's shown to the right. And that translated into significant work and engagement in the Barberton area, where there was previous work on early life, essentially by Maarten and other co-workers. So at the time, the structure of AEON looked like this. Essentially, you have the tools, the hub on the left, on the right, sorry, the corridors being the umbrella, linking it to an Africa Alive program that is meant to provide basically the corridor content in the form of usable products to the community and society. And of course, you have earth services, education, and tourism and publishing. So again, a lot of work went into it. As it often, it has been incomplete to date. So, of course, the corridor is also expressing, in a way, the challenge that is Africa, given its size, as illustrated here, and also all the issues that were raised earlier. Now, around Barberton, we also did good work, and particular contribution into that was about an airborne survey that took place in the Barberton area. And to the right, the image, color image is showing you the data that was collected from the gyrocopter at the bottom left. And you can see major structures outlined on the color image, and the correlation to the geology and lithology essentially is in the map in the middle left. So that's basically showing you that we are picking up good geology from the data set. And of course, one can manipulate in different ways to highlight the structures that you want. This is an example of such treatments of the data. Now, I'm moving to the third milestone of the story, and that is the setting up of an Earth Stewardship Research Institute. At the time, we moved to the Nelson Mandela University. You can see here the listed key people who have been involved, and most are still involved with AEON. So that's just to show you how it looked like. Of course, the structure that you have just seen with the Africa Alive corridor linking the common tools and the research and development to the services is going to change when we put now in place the full Earth Stewardship Science. We focus on our commons. And I will just now give you some brief definition, and because some of you would be wondering, what do we mean by Earth Stewardship Science? And Earth Stewardship is the ethical, democratic management of physical and living systems of our planet. Earth Stewardship Science is a broad intellectual field in tune with contemporary global perspective of the world and its complexity, providing a far broader focus of study than that of climate change, sustainability science, development studies, ecosystem science, or earth system science, where we started. Its consilience approach seeks a deeper understanding of people and planet issues of both local and global significance. I will leave it there. So you can see now that with this statement, it's bringing in perspective the wholeness of AEON in its vision and in its endeavors, particularly focusing on students. So that is why the new structure of AEON looks like this. Of course, you have many hubs. Each hub is basically managed, run by a scientist with expertise in the field. But at the top, the programs are really what AEON has been trying to develop and to implement. Of course, some of them are still upcoming, and I will show you something about Dunia Africa and Ipakade that's known. We have basically merged the earlier programs of Inkabaye Africa and Ikuri Africa into one. Ipakade and Indian Ocean, Africa Life Corridors, you've heard about that, and the Karoo baseline and beyond. So I will not say more about this, just to say that this has been, this remains now the structure of AEON. So our vision is essentially this, looking at bringing faculties together through Earthship science, and that will translate into transdisciplinarity, and touching on all faculties. And the diagram in terms of the four nodes speak for itself. Dunia Africa is basically what you have to the top left of the Earthship branch. Of course, here we are looking at resources, we are looking at deep probing of the Earth, etc. So this is a vision. Obviously, it comes with challenges, and it is for everyone to take a stake and hopefully finding ways to bring betterment to our commons, and that is the perspective we have recently. Now, I just want to say something about the transitionary baseline in the Karoo as the last point of activity of contribution. And this transitional baseline is really looking at the deep and shallow aquifer connectivity as early warning systems, but also at the geophysical probing of a critical zone. As far as specific contribution is. But of course, it is broader than that. As you can see, the critical zone defined in this context here include the upper lithosphere, the hydrosphere, pedosphere, and biosphere. So it was essentially on the back of a Karoo shale gas debate, and looking at these areas here outlined, the black lines here gives you the outline of the blocks that were taken by the companies, and part of which became our survey area. I will not talk too much about this. I think the time is running, but just to say that here we have done move to this a work that is closest to transdisciplinarity. And to the left, you have what was involved in this baseline research. It's people. It's what I call G3, GQ, for our geology, geophysics, and geochemistry, and ecology, botany, zoology. So this here in this middle, the picture is showing you the cover of a report, extensive report that came out of the baseline work, and it entailed significant trust building through active engagement in the communities. And of course, through that, developing what we've called a citizen science program also. So I thank you. I want to leave it there because I realize that many of the topics have been condensed in such a way that you are bound to have questions, and it's better to answer to questions and for me to go on for 1.5 hours. So I would like to thank you and leave it at that, and hopefully it conveys the story of the journey. It is very condensed. Thank you.
Moctar, thank you very much. That was wonderful and very informative. I'm sure for those people that that didn't know that legacy that that Maarten has left behind. So thank you very much for that. Just to remind the audience, so Moctar, don't keep sharing your screen. We'll get some questions now from the audience. I'm sure there are several coming through. For those of you who don't know, you can type your questions into the Q&A bar on the right-hand side of the menu there of your screen. And so send some through. We'll give you a few minutes to type some questions up. And we already have one from Lou Ashwell. So Moctar, I'm going to read out the question for you.
Okay.
And it's actually a question that I had as well. So thank you, Lou, for being faster than I. What is the future of AEON in terms of leadership, the progress of existing activities, and the development of new initiatives?
Well, from Lou, I was expecting that. Lou, I can say it is too early, but what we are decided upon is to keep AEON going. Now, of course, it is easily stated than done, but my immediate challenge and that of the team working with me today is to keep the many students that Maarten had going through their thesis. There are many PhDs, etc. And also by doing that, maintain some of the projects that feed into the bigger AEON program and vision. So that is a minimalistic answer to your question. Of course, a lot still needs to happen, and there are multiple sides to what needs to happen. There are institutional issues. There are the funding is a critical component of the challenge ahead. Etc. So I would like to leave it at that, but this is top in our mind, and I'm sure with everyone who has been closely working with Maarten and linked to AEON. Thank you.
Thanks, Moctar. And Lou also makes the point. Thank you for the nice talk and for all you have done for Africa throughout your career. And thank you, Lou, for the question. We have another question here from Anonymous. Can you comment more on the citizen science and community engagement in the Karoo project?
Yes, basically in the citizen science, because as you know, the Karoo project started really with the issue around water. That was central to the communities in the Karoo. And as such, we have focused the citizen science on not only on training first the youth, unemployed youth, in being able to do water sampling and read a basic, take basic measurements of the water in terms of salinity and other parameters, and also telling the communities what the science and the industry of shale gas is all about. So that was really the primary drive. Of course, following the intake of unemployed youth in the communities for citizen science program, we have had a PhD coming out of it, and that PhD person now is ready to continue with that and in the Karoo and develop it further. So as we speak, we are looking at proposals to expand that work.
Okay, fantastic. We have a few more questions here, Moctar, if you have some time. So the next one is from Anonymous. What other questions or geoscience challenges is AEON hoping to address with or through the transdisciplinary approach?
Well, one has to see that the context in which we wish to push the transdisciplinarity is through Earth Stewardship science. So that's basically creating Earth stewards is ultimate goal. And that is training a new generation of students who become Earth stewards. And through everything I've mentioned, it has implications for all of those aspects. But of course, transdisciplinarity would rely on the fact that you have also different disciplines that are strong to drive various aspects of a science. So the questions are multiple, and as you know, scientific research is not like selling a product. There is a development. You need to drive research development to a point where the person is able to take on it, and depending on interest. So there will be a focus on guiding through that, but one cannot preempt what kind of topic will come out of it. Essentially, it is everything. So, and I think I want to leave it at that. It is a very broad subject, and we cannot predetermine specific questions, but everything to do with Earth Stewardship science that I've mentioned is included in that.
Okay, this is sticking to the same theme, and I think also an important question from Anonymous. To what extent do you think AEON has demonstrated the value of transdisciplinarity, and how can this be deepened across the commons?
It is early days. We have had 5 years, and you can imagine by the history how long these type of processes do take. So 5 years is short. So we have seen a first report, a first cumulative result coming out of it. Obviously, more work is needed to expand, and more people need to be brought on board to work along the same, this very concept of transdisciplinary science. So the last part of your question is really, in order to answer that, I want us to first take a step back. How much resistance is there to transdisciplinarity? Are most scientists still interested in staying in their silos or not? So that's a real question. So I think it will take breaking away from that and meeting each other. So that's what it takes. And it cannot be prescriptive, and that's basically goes for every research endeavor. You cannot prescribe. So we are effectively hoping that more people will come on board, that the world is going, and examples are starting to show that there is value in working this way.
Okay, and then we have one last question from Ray Durheim. Moctar, in your view, what is the likelihood that the Karoo will be fracked for shale gas?
Well, if I may just bring this into context a bit, when the whole debate started, and both Ray and I were involved, he has been leading part of the work that was done, so when it started, really, it was as if exploration, at least reconnaissance, will begin immediately, but many things have happened since, and from where we are, the price of shale oil on the global market, and specifically in the US, is almost in the negative. So and so one need to be, I think, if I was to be forecasting anything in that, I would be, worse than any forecaster you have ever heard. So, but point is that there is likely resource when the time is right, and because it has been clear enough that in South Africa, by our own, we don't have a means to exploit this resource in a way that is also taking into account the communities. So we don't have a means to exploit ourselves. So it will mean we have to wait for better, for the oil price, for energy to pick up. But once you say that, Ray, the issue then becomes, are we looking ahead long enough with new developments? Major car manufacturers are moving to electric, etc. So, and all other aspects of that means oil. So, looking ahead, are we really seeing many decades to come of oil? So I'm just putting those points to contextualize my answer. It is going to take a while before anything happens.
Okay, fantastic, Moctar. Thank you so much. I'm going to end off with one last comment that I just pushed through to the Q&A chat from Anonymous. Transdisciplinarity is a huge challenge in the world of science, and we commend AEON for forging ahead and building a new generation of scientists. And I think that everyone who's watched your talk today, Moctar, will agree with that sentiment, and thank you, and of course Maarten, for all the incredible work that you and your team have done. So on that note, I'll say thank you once again to Moctar. I'll say thank you once again to John Hancock and CCIC for sponsoring these online Geotalks, which we hope you are enjoying. But that does not mean that the interaction has to end there, because we have tried to institute our quota of social geo interaction during these lockdown times, and so you can join us for a social Zoom gathering after this. This is the Zoom link if you want to join us, and it's really just a bit of fun and a bit of networking. So bring along a drink, and we'll see you in the Zoom session very shortly. Moctar, thank you very much. I'm very quickly going to just share the talk for next week so that the audience can see that. And
thank you.
You will see here that we have Refiwe Shelembe from the Council of Geosciences, who will be discussing a very topical notion for students. And I think it would really encourage any students that you know to watch this. The talk is titled, "It All Starts at the Bottom. Geoscience Still Matters." So we hope that you will join us for that, and we look forward to seeing you in the audience next week. Thank you very much.